Hello everyone, am I audible to all?
Yes, ma'am.
Good morning, good evening everyone. My name is Priyanka and I am the executive at International Bauxite, Alumina and Aluminium Society. I just want to inform you that Dr. Ashok Nandi, who is the president of IBAAS, cannot join us for today's lecture because he is in Guinea and he is working on some important projects there. So, on behalf of him, I welcome you all to the IBAAS JNARDDC Technical Lecture Series 2022 Lecture 3. Today's lecture will be presented by Dr. Anupam Agnihotri, who is the director of Jawaharlal Nehru Aluminium Research Development and Design Center. And the topic of the presentation is Aluminium, a Sustainable Resource. Just a few suggestions before we get started. This is a recorded presentation. Please let us know if you encounter any problems. Also, if you have any questions during the presentations, please drop them into the chat box. I will bring them up after the presentation. Now, without further delay, let's start the presentation.
Dignitaries on this VC platform, invitees, participants, attendees, members from media, ladies and gentlemen, a very good evening. At the outset, I extend warm greetings to all of you here, and in fact, it is honor and privilege to share my thoughts on aluminium, a sustainable resource in this webinar series 2022 organized by IBAAS. I'm happy to know that IBAAS provides a platform for aluminium industry professionals to interact and work together with common goals for development of Indian aluminium sector. It is also interesting to note that efforts are being made to further expand the activities of IBAAS to BRIC countries, seeking in the process cooperations from similar organizations in the US, Australia, and Canada. I am grateful to Indian Bauxite, Alumina and Aluminium Society, IBAAS, for this nobility to let me share my views with the elite and eminent audience on this platform. Before talking about aluminium as a sustainable resource, we have to look into the definitions of sustainability or the true meaning of sustainability. If we look into the definition of sustainability, there are more than 200 definitions of sustainability, and the most common one is that sustainable development is a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Now, looking into the sustainability, there are three pillars of sustainability known as environmental sustainability, economic sustainability, and social sustainability. They are all intertwined, they are all dependent on each other, and they all affect each other. These three pillars of sustainability provide a framework for applying a solution-oriented approach to sustainability issues of metal sector and as well as aluminium in particular. Environmental sustainability focuses on well-being of the environment. This pillar includes water quality, air quality, and reduction of environmental stressors such as greenhouse gas emissions. The environment also provides natural resources necessary to foster economic sustainability. Sectors rely on extraction of natural resources to be economically sustainable. Efforts to extract resources at levels that are sustainable for environment also provides economic sustainability through the continued availability of the resources. Economic sustainability includes job creation, profitability, and proper accounting of ecosystem services for optimal cost-benefit analysis. The social sustainability includes environmental justice, human health, resource security, as well as efficiency and education, among other important social elements of the society. Under this three-pillar concept of sustainability, efforts to promote social sustainability also aims to foster economic and environmental sustainability. Economic and social sustainability put together gives you an equitable environment. Social and environment sustainability is something known as bearable environment, and if we have only two of that is economic and environmental sustainability, it's something which is viable in the process. Talking about the sustainability of aluminium without considering the Sustainable Development Goals, also known as SDGs, set by United Nations Agenda 2030 will not be of justice to aluminium sector. Recent years have seen a growing interest in and awareness of impacts of industry, particularly in the areas of environmentally responsible production, sustainability, and socio-economic contribution. Worldwide, aluminium sector is already committed to improving and upgrading industry performance in all these areas. United Nations in 2015 have adopted the Sustainable Development Goals, as I told you, known as SDGs, are also known as global goals as universal call for action to protect the planet and ensure that by 2030, world is environmentally, economically, and socially sustainable. The 17, as you can see on the screen, the 17 Sustainable Development Goals, known as SDGs, are integrated in a such way that recognizing action in one area will affect outcomes in others, and that development will balance social, economic, and environmental sustainability. The creativity, know-how, technology, and financial resources from all of society are necessary to achieve the SDGs in every context and have been made integral part of the 2030 agenda items by United Nations. The Sustainable Development Goals set by United Nations as a part of its 2030 agenda are acknowledged as a framework for sustainable future of the world. As you can see, the SDGs, there are 17 global goals, and among these 17 SDGs, there are 169 targets covering economic growth, social inclusion, and environmental protection. The agenda states that all countries and stakeholders acting in collaborative partnerships will implement this plan. Governments in many countries are developing strategies and practices to achieve these goals. And in parallel, organizations at various levels, such as local governments, industries, civil societies, which are regarded as stakeholders in the agenda, have been requested to commit to the SDGs. In fact, I'd like to share with you that Government of India is also committed to working on these goals, and JNARDDC has been assigned the task for formulating draft policies, guidelines, standards, and many more to meet the circular economy targets in non-ferrous metal sector, which includes aluminium, copper, lead, and zinc. I'll discuss these details in coming slide. Now, if we talk about SDGs, as I showed in the previous slides, there are 17 SDGs which may or may not directly impact the aluminum sector. The detailed analysis was done to identify the SDGs which have highest impact on the aluminum sector, and the focus was to maximize its ability, the SDG's ability to change and build business opportunities. So you can see the 8 are like quality education, gender equality, affordable clean energy, decent urban economic growth, industry innovation infrastructure, responsible consumption production, that is very important, climate action, and partnerships for the goals and targets. These SDGs are aligned with the 4 priority areas I'll be discussing later, covering the most significant topics for aluminium, representing areas where sector either has significant economic, environmental, and social impacts, or that sustainability influence the assessments and decision of its stakeholders. Aluminium as a sector or as a metal offers a solution to many of the world's sustainability challenges. It can enable its low carbon, resource efficient agenda and support long lasting growth and a more competitive world economy. The aluminum industry and other business to business sectors may find an abundance of opportunities for further commitments to the SDGs by considering the values and benefits that their output create throughout the value chain. Knowledge and experience of the life cycle analysis will definitely assist in creation of an assessment framework, sustainable roadmap, which is an important point in SDGs. Now, looking at world aluminum production, which was 86.2 million tons in 2020, was about 90 sometime in 2018. It has come down. Mostly it was a COVID effect. Aluminium, which is often referred as the green metal, thanks to its high strength to weight ratio, long lifespan, corrosion resistance, and the fact it can be effectively recycled forever, melted down and reformed without losing quality. But the environmental credentials of this versatile material or metal are severely let down by its carbon footprint. The heavy industry sectors together emit, I shared the numbers, together emit more than 10 gigatons of greenhouse gas emissions, of which aluminum industry generates around 1.1 billion tons of CO2 equivalent or greenhouse gases, and definitely which is predicted to increase in coming years, accounting for 1.1 billion tons of CO2 emissions per year. The aluminum industry generates about 2% of global human caused emissions. The aluminum sector's CO2 emission or the greenhouse gas emission is mostly because of its reliance on energy intensive smelters, more than 60%. Demand for aluminum an essential metal for several key industries, including construction, transportation, and power transmission, is expected to grow by more than 50% by 2050, and so will be the greenhouse gas emission. Rapid population and the economic growth over the coming decades means global demand for aluminum is set to increase by about 50% of the present. That is, from 86 it will go to 140 million tons by 2050. This is as per IEA report 2020. This demand will be definitely met by a primary as well as secondary sector, because aluminum products have high recycling rates. Even with addressing the issues of collection of end-of-life aluminum products, the long lifetimes of durable aluminum products, a growing population, and broader range of application means that there will be not enough post-consumer scrap to meet this demand alone. So no doubt the primary metal will still be needed to be produced until at least the second half of the century. Growing public interest in environmental, social, and economic issues requires aluminum sector to address the United Nations Sustainable Development Goals. This slide talks about connecting the aluminum sustainability with the United Nations Sustainable Development Goals. And if you look into the environmental sustainability, there are 4 pillars: raw material sourcing, energy consumption, industry waste management, and greenhouse gas emissions. Exploring the aluminum industry's engagement with the SDGs is essential in accelerating its engagement with these goals. Talking about the first pillar, the raw material sourcing, the very first is source raw material from social, economic, and environmental perspective, and of course promote the traceability, which is an important part of life cycle analysis. Coming to the energy consumption, as it is known to everybody here that aluminum is known as a energy guzzler, the smelters there. So there has to be a reduced energy consumption by a fixed percentage, which will depend upon the technology being used to produce the aluminum. For industrial waste management in aluminum sector, of course, the rule is reduce and recycle industrial waste and minimize the landfill of recyclable waste. So this is how this particular issue of industrial waste management can be sorted out. Third is the greenhouse gas emissions, the relation of greenhouse gas reduction potential for 2050, which I'll be sharing in coming slides. So the pathway for all these 4 pillars is for creation for sourcing, improve the traceability. For energy, there has to be saving on existing technologies, development of innovative technologies across the whole value chain, starting from aluminum refinery, smelting, semi-fabrication, and recycling. Waste assessment of the value chain for industrial waste management, identifying the needs and treatment. Already the solutions are there. It's only the push is required from government side or industries and identify inter-industrial needs for waste consumption. For example, like the red mud can be a good source for a raw material for a cement industry, a source of energy. The SPL can be for the cement industry. So these inter-industrial needs are to be explored. Greenhouse gas emissions, yes, stability of energy network is very important since uh, the aluminum industry is dependent on captive power plants. Renewable energy sources should be a part of this program. Low carbon production technologies and advanced smelting technology are going to help to reduce the greenhouse gas emissions. So the promising pathways to emission reduction, I can say, should be focused on two things. One is the novel technologies, like what is coming up is the inert anode that eliminates the need for carbon anodes in smelting, and development of technologies that can provide heat and steam without combustion of fossil fuels. Example can be the electrification with renewable power sources, combustion of renewable produced hydrogen, concentrated solar thermal as a share of energy mix, and of course people are talking about mechanical vapor recompression of steel to recover the heat from the gas. In addition to this, the capture and sequestration of greenhouse gases from each source at point of emission or evolution is another possible potential path. Now coming to the circular economy, which is the heart of the sustainability of aluminum. As the circular economy is nothing but a framework that can tackle global challenges like climate change, biodiversity loss, waste, and pollution, which is based on three principles: eliminate waste and pollution, circulate products and materials, regenerate nature, means live as close to the nature as possible. For eliminating waste and pollution, definitely the designing of the products, material should be for circularity, eliminating waste. If not, then going for a value addition to it, substituting materials which are more recyclable, then circulate products and materials, reusing products and components as far as it can be, and recirculating the materials. So eliminate, circulate, and regenerate. So our take, make, waste linear economy is heavily extractive, resource intensive, and produces greenhouse gases that are causing the climate crisis, and it's high time to move on to circular economy from the linear one. Because the reason is the world is still not close to being on the track to limit the temperature rise to 1.5 degrees centigrade in 2100. This is despite the commitments to that effect being made by about 195 countries who have signed the 2015 UN Paris Agreement, and actions to reduce emission being put in motion. By 2050, the global population is projected to reach about 10 billion. It is predicted that an emerging market middle class will double its share of global consumption from 1/3 to 2/3, and the world economy is expected to quadruple. So urgent coordinated actions and far-reaching transformations will be need of the hour. Systematic change in energy and industrial systems, land management, building, and infrastructure will be needed to put the global economy on the track to reach net zero emissions by 2050 and therefore limit global warming to 1.5 degrees centigrade, and circular economy can play an important role in this. By shifting the economy from linear to circular, there will be shift of the focus from extraction to regeneration. Instead of continuously degrading nature, we build natural capital. Reducing aluminium's carbon impact is one of the essential activities to make this metal sustainable. And as you can see the numbers here, like there has been a reduction in PFC emissions since the early 90s by 85%, and carbon footprint has been declined by 49% in 1991. So with these numbers around, we can definitely say that aluminum production is more sustainable today than it was yesterday. The reduction in the carbon impact of aluminum sector is due to a decrease in PFC emissions with latest technologies of anode effect prediction and much better cell controller, reduction in energy consumption. Energy consumption on an average for aluminum sector worldwide has been reported to about 14 kilowatt hour per kg of aluminum. This is as per International Energy Agency, and of course reduction in the carbon footprint. All these have been due to voluntary efforts and technology improvements, the expanded use of renewable energy source, hydroelectric power source for aluminum production, which has zero emissions attached to it, and this has increased from 63% in 1995 to 75% today. There are upcoming innovative technologies which will be commercialized in 2023. The technology known as LCIS, which uses the inert anode and there is no greenhouse gas emission in that technology, and it is going to make future primary production even more sustainable in coming years. The aluminum sector is an integral part of sustainable economy, but as a carbon-intensive industry, we will need to proactively address its sectoral carbon footprint. And aluminum sector has brought down the carbon footprint to half over the last 30 years. As decarbonization efforts are accelerated across the world, aluminum sector has a vital role to play in path towards net zero. The life cycle assessment report has found that carbon footprint, as shared earlier, has been declined by 49%, and the footprint of recycled aluminum production has dropped by 60%. During the same period, the energy needed to produce the primary and recycle can be is also referred as secondary sector, has dropped by 27% in the primary and 49% in the secondary. Even if you see the last 10 years, somewhere between 2010 to 2020 alone, the carbon footprint of aluminum primary production has declined by 5%, and that too of secondary has declined by 25%. Aluminum sector is committed to increasing recycling rates and is working on multiple fronts to accomplish this goal of increasing the aluminum recycling rates. This includes advocating for recycling infrastructure improvements and other policy changes to incentivize the increased collection and capture of the used aluminum, that is end-of-life aluminum. Improving recycling rates will not only help the aluminum industry reach its sustainability goals, but will reduce energy usage and bring us closer to ultimate goal of totally sustainable development. In spite of the fact that there has been growth of power generation through fossil fuel, but industries focus on eliminating process-related emissions such as high global warming potential gases, that is known as PFCs, from anode effects, improving energy efficiency, and adding new and the best available refining and smelting technology has led to this reduction of carbon footprint. Total direct emissions constitute less than 1/3 of the total sectoral emissions, with PFC making up only up to 3%. The anode consumption in smelting process and fuel consumption across all production processes make up almost all the direct emissions from the sector. Some 77% of aluminum sector CO2 emissions are generated in the smelting process, of which more than half, say about 64% of sector-wide emissions are due to electricity usage through fossil fuel. Now coming to the global carbon dioxide emissions from 4 key material production, in which aluminum is one of them among the 4 materials. The circular economy can reduce the global carbon dioxide equivalent emissions from cement, steel, plastic, and aluminum production. This can be reduced by 40% by waste elimination, product reuse, materials recirculation, and circular scenario of 2050. So it can be reduced by 40%, or say about 3.7 billion tons by 2050. That will be almost half of their net zero emissions target. The primary aluminum carbon footprint by 2050 has to be brought down to about 5 tons CO2 equivalents per ton of aluminum. This is what the graph shows. 2018 has been the baseline. If we see the business as usual scenario, as well as the scenario of beyond 2-degree scenario by 2050. So it has to be brought down, and there has been indicated range of performance depending upon the energy use and the technology use. The opportunity comes from making better use of products and materials with key sectors such as built environment and mobility. These solutions are cost-effective and offer system-wide. Increased recycling reduces carbon impact, which simply implies that aluminum recycling makes the industry more sustainable. Because recycling of aluminum is 94% less carbon intensive as compared to the primary production of aluminum. We share the numbers, how useful the aluminum recycling is. Increasing the aluminum recycling rate by 1% can reduce the overall product carbon footprint by 80 kg of CO2 equivalent per 1,000 kg of aluminum produced. The important point is that aluminum should not go into the landfills at any cost, because this is loss to economy, environment, and of course the energy. Government of India is committed to increasing aluminum recycling rates and is working on multiple fronts to accomplish this goal. And one of the activity is of setting up a metal recycling authority in country for non-ferrous metals. This assignment has been given to JNARDDC. This will help in advocating for new investment in recycling infrastructure and other policy changes to incentivize the increased collection and capture of used aluminum, that is, aluminum scrap. The environment benefit of recycling can be quantitatively calculated simply by comparing the cradle-to-cradle primary energy demand and carbon footprint associated with primary metal production and recycled metal production. You can see here that recycling saves 93% of energy and reduces 94% of carbon footprint compared to producing the metal from bauxite route. For higher recycling rates, policymakers need to develop smart and effective policies to incentivize quality recycling. The scrap collection industry needs to invest in new infrastructure to meet current and future demand. Recycled aluminum has the lowest greenhouse gas intensity, and if you see the number, it's about 18 tons of CO2 per ton of aluminum is more than 7 times the emission issued with producing 1 ton of primary steel. So that is for the primary production. Emissions can be reduced using low carbon sources because remelting requires, as it is known, only 5% of the energy as compared to the primary route. No doubt, aluminum is a perfect material for recycling. The reason it can be recycled over and over again without losing its functionality. When properly collected, sorted, and segregated, the recycling process does not change any functionality of the metal, regardless of how many times it has been recycled. While aluminum products for transportation, infrastructure, building and construction, durable goods have been historically mostly recycled at the end of life, the recycling rates for consumer products such as packaging are far from expectation. The recycling industry will not only help the industry to reduce its environmental footprints, but also help society to save the aluminum recycling industry should call on all stakeholders to work together to improve on aging recycling system to meet the 21st century demand for optimal use of planet's scarce resources. Now, connecting the aluminum sustainability with the SDGs, that is Sustainable Development Growth, for economic sustainability. Previously, I shared was that environmental sustainability. Now, here it's economic sustainability in terms of the product. Aluminum improves lifestyles while minimizing environmental impacts. This is all due to its amazing properties, what we call the aluminum thread. It is the material of choice for many applications. And no matter what we use it for, it can be recycled over and over again. Aluminum products are essential enablers of a low carbon future, and the increased use of metal will lead to reduced economy-wide emissions. Fleets of lightweight autonomous electric vehicles delivering least mobility services to growing global population powered by renewable energy grids is going to help the sustainability. Net positive, modular, intelligent buildings producing more energy than they consume and adapting in real time to the varied needs of their occupant will help to attain the Sustainable Development Goals of Agenda 2030. Lightweight and protective packaging solutions bringing nutritional and pharmaceutical benefits to people by 2050, minimizing wastage and reducing burdens on logistics will help to have a worldwide better economy as compared without aluminum. All we require the material and energy benefits that aluminum brings and in increasing quantities. The overall goal for all products is to unleash the aluminum effect and support the circular economy. As the world around looks for sustainable future, aluminum is uniquely positioned as the material of choice. No matter the industry, innovators rely on aluminum for greener and more sustainable solutions. While aluminum is the part of solution for sustainable future, increasing demand for aluminum will only be enhanced by transition to a low carbon trajectory. And such paths will be different for different sections within aluminum sector around the world and along the value chain. Aluminum's unique sustainability and infinitely recyclable property supports a more circular and sustainable economy. There is a need for sector-wise and inter-sectoral partnership to address the huge challenge of aluminum sustainability while satisfying growing demand. In future, partnerships will be required among and between producers as well as the public sector and academia, power generators, semi-fabricators, customers, OEMs, and end users. Due to its relative homogeneity in terms of processes and products, along with scale and global scope, the aluminum industry can meet the need. The figure shows that recycling of 3 beverage container materials, aluminum, glass, and plastic, shows that aluminum cans can best support the circular economy. The studies have also shown that compared with aluminum cans, more glass and plastic bottles end up in landfills because they are not collected. In addition, the losses in recycling system once collected is 3 times higher for plastic and glass bottles as compared to aluminum cans, and all this supports the statement that aluminum is uniquely sustainable. Uniquely sustainable aluminum is positioned as the material of choice, which makes good products great and great products even better. Aluminum beverage cans contain 3 to 12 times more recycled content than competing packaging types. When used for construction, aluminum structures can weigh substantially less than steel while providing comparable strength. An aluminum intensive vehicle can achieve up to 20% reduction in total life cycle energy consumption. Aluminum's low weight not only means you can do more with the less, but also it takes less energy to transport the metal from one place to another. Thanks not only to aluminum's recyclability, but also its durability and resistance to corrosion, nearly 75% of aluminum ever produced is still in use today. The aluminum industry is constantly innovating, seeking new ways to lower emissions, increase efficiencies, and strive towards more sustainable future. Once again, connecting the aluminum sustainability with Sustainable Development Goals of Agenda 2030 in terms of economic sustainability and mobility plays an important role in that. By virtue of its lightweight, crash energy absorptive, and fully recyclable characteristics, aluminum shell enable the transition to low carbon and safe mobility, representing the material of choice for design engineers of the future. Industry will require to develop, implement, and monitor the progress of aluminum recycling for automotive industry, considering design for dismantling and recycling of aluminum parts and maximizing the quantity and quality of recovered aluminum scrap. Facilitate the manufacture of even more fuel-efficient vehicles by engaging in research projects. Promote the use of aluminiums in car, trucks, buses. Reduce energy consumption and CO2 emissions in transportation by advocating for improved vehicle efficiency standards, better and harmonized labeling, and higher visibilities and awareness of weight of the vehicles. In the automotive industry, lightweight is continued trend that does not show signs of decline. Global trend towards CO2 reduction and resource efficiency have significantly increased the importance of lightweight materials and design over the last years, and aluminum fits in best here. The CO2 limits are continually being lowered in the global automotive markets. And to share with you, the 9 governments worldwide, namely Japan, EU, US, Canada, China, South Korea, Mexico, Brazil, and India is also part of that, have established or proposed fuel economy or greenhouse gas emission standards for passenger vehicles and light commercial vehicles. The regulations in these markets, covering 80% of global passenger vehicles, influence the business decisions of major vehicle manufacturers around the world and are among the most effective climate change mitigation measures to have been implemented over the last decade. Again, talking about the aluminum sustainability with reference to SDGs of Agenda 2030 under economic sustainability and the role of aluminum in construction industry. Aluminum has high durability, design flexibility, lightweight and fully recyclable characteristics, and it is an essential component of energy efficient and sustainable buildings, both in residential and commercial sector. The construction industry has to develop, implement and monitor the progress of aluminum recycling for the building industry, investigating the relevance of design for dismantling and recycling aluminum products, and maximize the quantity and quality of aluminum scrap. It also has a responsibility to facilitate the development of new solutions, further enhancing buildings' energy efficiency, durability, comfort, safety, and low maintenance requirements. It has to address the durability of aluminum products' performance and their adaptation to climate change and ways of living with increasing critical solution. Aluminum is the second most widely specified metal in buildings after steel and used in all construction sectors from commercial to domestic buildings. The main market sectors are windows, roofing, cladding, curtain walling, structural glazing, prefabricated buildings, architectural hardware, shop fitting, and partitions. The ability to recycle aluminum building products is also becoming more important as more building owners decide to deconstruct rather than demolish older buildings. Instead of simply going with a wrecking ball, owners are now much more deliberate about how they can take down a building in order to extract as much recyclable material as possible. By doing so, they not only retain the scrap value of material such as aluminum, but also eliminate the environmental impact and cost of dumping it in landfill. Now to share the JNARDDC's role in Government of India's program for SDG Agenda 2030 and circular economy. The very first program under circular economy initiated by Government of India in metal sector is the zero waste management policy in line with zero discharge to encourage utilization of various waste and improving sustainability in metal sector. Steel plants and producers, JNARDDC is working for the four non-ferrous sector, that is aluminum, copper, lead and zinc. The timeline given is 3 months. In fact, a draft zero waste policy comprising of various utilization options and responsibilities has been compiled for approval of Government of India. This is a glimpse of a draft policy, zero waste management policy to encourage utilization of various waste and improving sustainability in primary aluminum production. This is for aluminum sector, which covers various waste generation and their sources, definitions, targets, responsibilities of stakeholders, waste utilization and management, procedure for grant of authorization by SPCB, CPCB, sampling, storage, handling and transportation of waste, standards, monitoring and reporting are all covered under this draft. Similar kind of work has been done for copper, lead and zinc. This is a draft policy for zero waste management in primary copper sector, and similar kind of topics have been covered as discussed in the aluminum policy. Similarly, draft policy for zero waste management to encourage utilization of waste and improving sustainability for the zinc sector has been prepared by JNARDDC for Government of India's approval. Fourth and the last draft policy for zero waste management for lead sector has also been prepared, and this was done in discussion with stakeholders. In fact, all the four policies have been done with discussions and meetings with the stakeholders. The Institute is also working to develop guidelines for environmentally sound management of red mud, under which there is a proposal for mandating use of dry stacking of red mud in alumina refinery, mandating use of red mud in cement industry. There are non-mandatory uses of red mud also has been discussed, and working on framing up of separate rules and guidelines under hazardous waste rules 2016. So the center is collecting the utilization practices from Indian alumina refinery, benchmarking the existing practices depending on the best, then collecting best available technologies globally, followed on storage and utilization of red mud. Stakeholders consultation has been done. Draft rules and guidelines are under preparation, and I think within a period of 2 weeks' time, this will be also public. Then another activity is guidelines by CDCP for mandating use of spent pot lining in steel industry as an alternative fuel. This is also kind of a mandatory use of SPL in steel industry. The timeline is 6 months. Draft guidelines for mandatory utilization and dry stacking is under preparation. Stakeholders meet is over, and whatever best available technology available in the world for usage of spent pot lining are also covered in this document, and these guidelines will be very soon published for public opinion by Government of India. Institute is also working for formulating standard operating practices and compliance to air pollution norm for recovery of zinc from electric arc furnace dust of steel industry. This is for zinc sector. Timeline is 6 months, and draft SOPs and guidelines are under preparation after consultation with zinc sector. Very useful activity is being carried out under this program of circular economy in metal sector for EPR provisions for different waste and scrap of for effective utilization, making the industry responsible for the waste. Initially, the SPL has been selected under this program. Few components from the automobile industry and food processing are also being studied to be covered under EPR Act. This EPR is also a part of Metal Recycling Authority's activity. It will be covered in that also, so it is covered in MRA as well as circular economy activity for aluminum, copper, lead and zinc products. As informed earlier, that JNARDDC has been given a responsibility of Metal Recycling Authority. This is on temporary basis for the time being until approval from the cabinet is there. So JNARDDC is working as a Metal Recycling Authority for aluminum, copper, lead and zinc. The objectives of this Metal Recycling Authority will be to promote recycling, have an organized recycling ecosystem, and work towards economic wealth creation, job creation, and increased contribution to GDP through metal recycling. This was an outcome of National Non-Ferrous Metal Scrap Recycling Framework 2020, published by Ministry of Mines, and all activity are leading toward shifting from linear economy to circular economy in coming years. And the timeline to shift from linear to circular for the metal sector given is 2 to 3 years. Vision of the Metal Recycling Authority is to organize non-ferrous metal recycling sector, improve quality of recycled product which has been issued, and increase the visibility and support to the recycling industry from Government of India's point of view. The authority will act as a facilitator to implement the non-ferrous metal scrap recycling framework, and some of the major responsibilities of MRA will be to standardize the recycling practices, devise and maintain data bank for recycling value chain, inspection of the recycling units, technology improvements, and development of infrastructures like recycling zone, etc. These are the set of various documents, draft standard documents or guidelines prepared for the roles and responsibilities of MRA regarding minimum infrastructure requirements for non-ferrous metal recycling, certification of products, minimum recycled content, processing of end-of-life aluminum scrap, processing of end-of-life of copper scrap, lead scrap, and green scrap. Now, the aluminum sector pathway to sustainability. Despite increased projected recycled metal supply, the IE estimates that up to 90 million tons of primary aluminum will be required. So there will be more of a greenhouse gas emissions, which has to be controlled. IE is exploring realistic and credible technology pathways for 2050 for sector-wide greenhouse gas emission reduction. Under B2DS, that is beyond 2 degree scenario, the industry would need to reduce its total emissions to 250 million tons of CO2 equivalent from 1.1 gigatons of CO2 that was there in 2018. To achieve this, the identified broad pathways for the emissions are electricity decarbonization, direct emission reduction, recycling, and resource efficiency. All pathways will be a mix of technologies, including existing, new, under development, and yet to be developed solutions. So the next generation of primary aluminum, which will lead to its sustainability and of course meet the agenda of sustainable development goals 2030 of United Nations. The revolutionary technology will eliminate virtually all direct greenhouse gas emissions from production of new aluminum, that is by using inert anode. The game-changing innovations has the potential to make aluminum already one of the most sustainable materials on the market today, even much more greener than what it is. Already primary aluminum production in the world is cleaner today than it was earlier, and the carbon footprint has already been reduced to 50% to its 1991 value. So the aluminum industry is not only growing due to its increasing demand of its product, but is also in a state of structural transition towards a new center of production driven by access to long-term economically attractive energy, the growth of new markets, and availability of raw materials. So aluminum offers solutions to many sustainability challenges. It can enable its low carbon, resource efficient agenda and support long lasting growth and more competitive world economy. Thank you. Thank you very much. And I'm grateful to Indian Bauxite, Alumina and Aluminium Society, IBAAS, for this ability to let me share my views with elite and eminent audience on this platform. Thank you very much for being with me. Thank you. Dignitaries on this VC platform, invitees, participants, attendees, members from media, ladies.
Dear participants, please note at present Dr. Agnihotri sir is traveling. So he will join us within 10 minutes. We request you to please stay connected for question and answer session. Dear participants, unfortunately, Dr. Agnihotri sir cannot join us for question and answer session because still he is traveling. So I request you to drop your questions in the chat box. We will forward them to him. He will shortly send you the answers by email. Thank you everyone. We appreciate you being here. Thanks again for joining us today and we will see you next time. Thank you.